This week, our topic is equipment and application tools with Jeff Sanders. Jeff has been working with NoTill systems for 6 years with UVM Extension. Previously, he was an active dairy farmer on a large dairy in northern Vermont. Jeff has worked hard over the past years refining no-till systems in northern climates, and he's very happy to share some thoughts on no-till equipment and application tools with you this morning. So I'm going to hand this over to Jeff at this point.
Down through to here. So the definition of no-till, there's a bunch of different ones. The Webster Dictionary says it's a system of farming that consists of planting a narrow slit trench without tillage, with the use of herbicides to suppress weeds. So they're recognizing that herbicides play a role in this in many cases. Phillips and Young, out of a book, and Young was one of the fellows down in Kentucky that brought this back, or reintroduced it back in the 50s. No tillage can be defined as a system of planting, seeding crops into untilled soil by opening a narrow slaughter trench only sufficient width and depth to obtain proper seed coverage. No other soil tillage is done. That's a pretty pure view of no-till. NRCS defines it as limiting soil disturbance to manage the amount of orientation and distribution of crop and plant residue on the soil surface year-round. So they take a little bit different approach of it. They're looking at it more from a conservation, soil erosion, soil building aspect. And then Vermont no-till is kind of what we practice here, and it kind of encompasses a little bit wider range of reduced tillage, no-till, and it's the implementation of a cropping system which drastically reduces the dependence on full width or depth tillage and increases the farm profitability and improves soil health. And so what we're talking about there is trying to get people to work more towards definition number 2, but recognizing that it's more of a journey, and people are at different points along that continuum from giving up the chisel plows and the moldboard plow and moving towards no-till. And there's people at different points in that continuum, and people that are facing different challenges in that continuum. And we go out west to a national no-till conference where everyone's growing grain. It's quite and has very different soils than here in the Northeast. And so what we see is that here in the Northeast, we have to contend with 8,000 to 10,000 gallons of cow manure per acre on a lot of our row crop land, and we have a relatively short growing season. And so there's some other issues that particularly manure presents with respect to soil compaction, risk of runoff, etc. And all the meanwhile, since I've been at UVM, we've also tried to ramp up the use of cover crops and make that part of the system. And so there's some challenges with that as well. So Vermont no-till, scratch till, the goal is to have people go to true no-till, but recognizing that it's going to take some time to get some farmers there. And so those are some definitions. Practical definitions of no-till for the intent of this course is really cutting the residue in soil to create a furrow of the proper depth, placing the seeds consistently in the bottom of that furrow, firming the seeds by applying the right amount of pressure exactly where it's needed, and then closing that furrow by chopping the sidewall to prevent drying and allow for good root exploration. So that's no-till in a nutshell. Really, it's very simple to do it right once, but the bottom of the slide, the trick is getting this right 99% of the time under varying field conditions. And so I highlighted a few words on this slide because I want us to think about it's very precise. You know, you're cutting the residue to the proper depth. You're placing the seeds consistently. You're applying the right amount of pressure exactly where it's needed, and you're chopping the sidewall. We're not smushing the sidewall. We're not compacting the sidewall. We're just chopping the sidewall. And so all those things present a whole bunch of challenges if we're going to rely on just the planter to do all that, and which is why we're trying to get folks to think of this more as a system than just a practice, because there's a lot of things that we can do away from the equipment to help the equipment be able to do these things. So along with that, you know, in a tillage system, so we're taking people from a tillage system and bringing them to no-till. And one of the things that I've seen on a lot of farms is that their corn planters, and I'm speaking mostly about corn planters this morning. I will talk a little bit about no-till drills towards the end, but a lot of the corn planters that we see on farms are really nothing more than seed droppers. The tillage has all been done previous, and really the only thing the corn planter has to do is drop seed and bury it a little bit, and the stuff in the corn will grow. And when we move to a no-till system, be it true no-till, scratch till, reduced till, we have to look at the planter much closer than we would in a conventional till system. And the no-till concept of doing these 4 steps is the same on every farm, but how it gets implemented on every farm is a little bit different. Everyone has different constraints, different soils, different soil drainage, different financial conditions. And so it's not one size fits all. It's really taking the time to work with the individual to develop a no-till system on that farm. And as service providers, it shouldn't be thought of as a one and done. I don't think any of us think that way, but we're just not going to walk in there, throw some row cleaners on a planter and walk away and have them be fine. There's much more to it than that. So I just want to make people consider that. The other thing to think about with the no-till process is the seed placement. It's a very important consideration. The slide doesn't really do it justice, but the placing of the seed in the soil is a 3-dimensional task. We want it at the same depth and the same distance between the seeds everywhere in that field. And so depth and spacing is critical, and it requires a properly maintained and set up piece of equipment. The depth is dependent on many things. I mean, I guess initially we would follow the seed company's recommendations, and then we would adjust from there depending on moisture content in the soil, forecasted weather, soil conditions at planting, and whatnot. Improper and variable seed depth is a major source of yield loss in no-till systems. If that seed's up and down in the soil horizon, or you're getting skips and doubles, that's going to be a problem, and the rest of the system can't compensate for that. The planter has to be set up to deal with that. We can't have that happen. And failure, the other major one is the failure to close the seed trench is a huge problem in no-till. It has to be addressed. The system has to be set up to allow for that to happen. And I guess above all of this, while you're planting corn, the system must be monitored to ensure that it's performing properly. If you go from, a lot of farmers will plant 3 or 4 or 5 or 10 fields in a day, and as the soil conditions change over those fields, the planter's got to be checked to make sure that it's still performing within the specifications that we're looking for. If you go from a clay soil to a sandy soil, you may need to adjust the down pressure springs. So when we're working with farmers, we need to, you know, in the no-till world, they need to be much more cognizant of these things. So it's important that they do that. And then I have this slide here. I know that some folks get discouraged when people pull out the tillage equipment. I'm one of them, and the purpose of this course is to help us service providers, help farmers make improvements in their cropping systems that will ultimately lead to a no-till system. And so I think it's important as service providers, we recognize why farmers might till, and so that we don't get discouraged. Sometimes there's a perfectly valid reason, given where the farmer's at in that continuum towards true no-till, that they would till, and some of those may include manure injection, field maintenance. Say they have a really wet year and the field's all ruts, they may need to smooth those out. And our goal is, as we move further into the no-till system over time, those rutting up the field would become less and less of an issue as the soil builds structure. Crop rotations. When farmers go from hay to corn, they may till, they may not till. But when farmers when they're rotating and go from corn to hay, they probably will till. They'll probably want to smooth that field up and get it ready to grow the grass, legume mix, or whatever they're growing. And so that's something to keep in mind that's likely to occur. Another source of tillage is to reduce preferential flow pathways into subsurface drainage. Recent studies have come out, and there's a lot of talk about preferential flow, where basically, especially in a manure system on dry ground, and in particular on hay ground as well as corn ground, manure can kind of fall down the cracks in some of these heavier soils that get fractures in them, and it can wind up very close to subsurface drainage lines and actually contribute to pollution. So there may be something in the future here in the Northeast that people may want farmers to actually do some very light tillage to kind of close those up. I think the healthier the soils become over time, the less likely that may be to happen, the fracturing, quite on the degree that these heavily tilled soils do. Also, some farmers may till to deal with heavy residue issues if their planters aren't properly equipped. And say a guy typically grows corn silage but decides to grow corn grain, and he's got all that stover out in the field, you may not have a way to deal with that comfortably without working that in somehow. So the goal is to move people away from tillage, but understanding that it's a learning curve. And I have a thing I wrote at the bottom here that says farmers will rely less on the old techniques as they become more comfortable with the new ones. And so that's kind of our job, is to help farmers move along and provide them with those tools and information they need to make better informed decisions about this. So I want to briefly throw this up. So it's important to understand, as people that we're working with farmers to talk about no-till, that the equipment part is really a small part of the entire system, and different farms will address the different parts of the system more or less depending on their knowledge and their support and a bunch of other factors. But the top image of the factors affecting yield came out of a publication like 5 years ago. I think it was a Soybean Digest. And what I noted, what's important to note there is that the tillage is the sixth most important factor in yields out of the 7 they looked at. And which is a strong case for no-till, in my opinion. If you build a system and you address the limitations in the system, the tillage becomes much less important. And that was an indication of that. And the bottom image is something that I put together, and it's not complete by any means, but there's a bunch of different aspects to the no-till system, which are going to be addressed through this course over the coming weeks and months. And the mechanical equipment part is only a small part of all that, but it does tie together with a bunch of other parts of the system. And so really, as service providers, we're providing the information and the education to the farmers to help them interact with all these other components of the system. And the most important thing is the psychology of the farmer and the psychology of the service provider. Everybody's got to be in it to win it, and that's the biggest determining factor, I think. And also, they're balancing trying to get their crops in against a bunch of other things. The biggest thing probably is weather. In Vermont, in recent years, there's been a slew of water quality regulations which farmers are adapting to, and no-till fits into quite well. And so it's a balancing act. And the no-till equipment is one piece of the puzzle, and it's just kind of linked to all the other pieces. And I have an example of that here. So this is a farm field that we worked on, and I guess it's to address the point that a no-till planter or planting equipment does not make a no-till system. Here's a field that we planted this spring, and so the practices that were on this field included, let me see, the farmer subsoiled the field, getting ready to go into no-till. He was gonna, from this point forward, do no-till. He wanted to get rid of the subsurface compaction. So he ran a set of subsoilers over it. He cover cropped the field, broadcast the cover crop on. You can see it's a little bit spotty in the middle. And then he injected manure on it, and he thought that if he ran a beam over it really light, he could cuff off the berms made by the manure injector. And so that's what he did. But when we went to plant this field, the equipment was fine. The planter was fine. We have a bunch of precision ag stuff on there, and I was having problems getting the planter to go in the ground. The sensors kept shutting off, saying the planter wasn't in the ground right. And you looked at it, the planter looked fine, but it wasn't. And so the image on the left shows where the planter actually mapped the gauge wheel pressure, which is also the down force on the planter. And you can see the headlands were red or blank. Blank means that the planter wasn't going in the ground far enough to trip the switch to tell the planter to measure it. And it's really just a matter of maybe a ½ inch in depth that would happen. And I couldn't figure it out because everything looked right. But the only tip off that I got was that the parallel arms on the planter weren't perfectly parallel. Everything else looked like the planter was in the ground. But anyways, everything the farmer did, where he went wrong was he ran a beam over it lightly, and that introduced just enough surface compaction with the spring that we had to where the planter just wouldn't go in the ground properly. And when we went back and looked at the field, the middle image is looking up and down the field, and it doesn't look that bad. He had a good, sprayed it off. It was roller crimp, and then he sprayed it, and it doesn't look too bad up and down the field. But if in the third image, if you look across the rows, there's a lot of skips, and the section in the lower left-hand corner of the field was quite bad. And we ended up replanting some of that corn. So it's just, if there's deficiencies in the system, the equipment isn't necessarily going to fix that. Although the precision ag stuff, which another speaker is going to address here in a few weeks, does help you monitor what's going on, and then that provides information back to the operator to make a decision on what they were doing. I probably should have stopped planting, but you're in a bind. And the one thing about the UVM planter is that it goes on a lot of different fields under a lot of different conditions, because we're trying to get the practice out there. I'll talk a little bit more about that in a minute. But what no-till equipment does do is it provides an opportunity for the operator to maximize their return on investment when the system is managed well. And we have two corn pieces. The one on the left was no-tilled into standing rye, had an excellent stand of corn. The farmer actually wasn't that happy with that, because this was a few years ago, before we figured out that we needed more nitrogen in the system, and he suffered a little bit of yield drag on that field because of the lack of nitrogen early. The field on the right, and you can see there's a farmer standing right here. This is no-till corn up in Franklin, Vermont. It's pretty bony soil. This farmer's been doing no-till for, I think, 5 years, and he's now getting consistently 20-plus ton corn yields. And this year was extremely droughty, and he still had amazing crop year. Definitely got some weeds around the outside of the field, but up and down the field, he had super corn. And the first year this fella did no-till, he averaged 11 tons of corn on his fields, but he didn't give up. He went back to the drawing board, made some changes, and kept with it. And now he's got a very resilient system, and he's got more feed. This year, he told me the other day, he cut back 10 acres of corn, seeded down 10 more acres, and still has more than enough corn. He's a small farm, milks about 100 cows. But so the system works. The no-till system definitely works. It's definitely profitable. It's about how we implement the system. And the equipment part of it is a key part, but it's only a part. It's not the whole system. So I'm going to talk a little bit this morning about roller crimping and planting green. It's been a lot of debate over the years at the National No-Till Conference about whether to plant green or spray it out and kill the cover crop, then plant. We've never really done much of spraying out the cover crop and planting into dead cover crop. The fear of having the plants pull out of the ground because the roots are no longer holding them because they aren't alive would create a huge problem with things binding up on the corn planter. So we've always kind of tended to plant green, and we've developed through some grants that we obtained a roller crimp system that's from Dawn Biologic. It's a ZRX roller crimper. And the image on the left shows that system working. It's pretty heavy cover crops. It was just from 2 years ago. We had a wet spring. Nobody could get out and do anything. The winter rye got pretty well out of control. Those probably like 5 foot tall. The rye there is tall enough to plug up the radiator on the tractor. And so we're just rolling that down and planting into it. Some of the considerations for this is the roller crimper on the planter definitely changes the dynamics of the planter. You can see on the image on the right, you have this big machine assembly on the front of the planter. And it's heavy, but more importantly, when this roller crimper is pushing down on the cover crop, it's actually picking the planter up. So you have to be very careful about how much down pressure you run on that, and how that changes the geometry to the row units in the back. So if you picture the planter with the wheels in the middle, and you don't want it tipping forward or backwards. You want it to run through the soil level. And depending on how you monitored the roller crimper, it could tilt backwards or tilt forwards, which changed how the row units performed in the soil, which changed how the seed was placed, which is critical. So there's a lot of paying attention to that system. It did require a lot of adjustment to get it right. And the biggest reason I think that was because the weight of the corn planter, and the same with a 4-row unit, is much lighter than, let's say, a 12-row corn planter. And really it takes quite a bit of weight to hold everything down in the soil when you're roller crimping and doing no-till at the same time. It does work. We've had very good luck with it. This year, one of our farmer clients saw higher yields on fields that he roller crimped versus fields he didn't, simply because of the drought. And that cover crop really does armor the soil and protects it from drying out as fast. And so they were very pleased with that. So there's that, and it does increase risk of insect pest damage, which I think people will be talking about at a later date. The traditional method of planting green, really just taking your no-till planter out, you set it up, set your system up, and you essentially just go out. The image on the right is you're going out into your standing rye and you're planting your corn or your soybeans, whatever you're planting. There's a few things to consider. You get the image on the left, just shows how tall the rye was. It was flowering, so it was quite tall. But the soil, whenever you're planting no-till, and particularly when you're planting green, you want the soil to be dry and warm. And the issue that we have is if you go too early, the soil may still be cool, and it could be wet. And there's a lot of, we've done work here at UVM that shows that cover crops dry the soil out quicker and may warm it up quicker. But what I think we've also found is that that's only for a certain period of time during the spring, when the plant's vegetative, taking up a lot of water, growing. Once it reaches the flowering stage, it kind of covers the soil and shades it. And so it can become a bit of a problem. I think understanding that when you're working with your clients, if they're planning on rolling in green covers or planting into green covers, that the planter be properly equipped, and then they're patient and understand what that means, and that's going to be an important thing. Another thing to consider is the cover crops themselves. I know NRCS folks and other folks encourage planting heavy covers for erosion prevention, building soil biomass, and when you're roller crimping cover crops, you do want the heavier the cover crop, the better. 100 pounds of rye growing super well. When you roll that down, if it's thick, it'll stay down. It'll become a mat. And when you roller crimp into 40 to 60 pounds of rye, it tends to bounce back up. It doesn't lay down good. And then on the flip side, when you're planting green traditionally, that 100 pounds of rye seed if you will, if that's what you're using. It's really too much. It introduces a lot of variability in the system, and we would recommend a lower seeding rate if you're just going to plant in without any special equipment other than a row cleaner or a coulter, which would be needed in either situation. And then another consideration is herbicide, which I'll show you in just a second. And the last consideration is fertilizer requirements. And what we know is that when you roll down or you put down the cover crop in the spring and you plant into it, that cover crop's going to immobilize quite a bit of nitrogen in the system. And what we figured out and what we've done is we've added nitrogen to the system through the planter or through other methods, but we've got to get more nitrogen near that seedling so that it has the nitrogen it needs to grow early on. And one of the things that we've done, there was a big craze, I guess, on pop-up fertilizer here in Vermont anyway for the last 15 years or so. And people are starting to go away from it. They're realizing that if you're using cow manure, a lot of the nutrient requirements are going to be met. The phosphorus requirements, the potash requirements are mostly being met through the application of manure. It's the nitrogen that's going to be lacking. Because especially if you spread manure in the fall, that nitrogen's at quite a high risk of becoming immobilized or whatever, not being available to the degree we'd like it to be in the spring. So a lot of folks are switching out their pop-up fertilizer programs and putting in more NPK based programs, like just putting on nitrogen. And under certain soil conditions and planting conditions, we do recommend that you still use some phosphorus. Especially cold, wet soils, it helps the seedling get started. So just a second on herbicide. Here's some pictures that co-worker Kirsten and I took down in Addison County. So what we did is we left a strip in this field, and you can see where it was roller crimped and then sprayed here and not sprayed here. And you can see that the corn's trying to grow up through these rows, but it's getting shaded out. The rye bounced back up, and really the rye is providing a lot of shade to a plant that wants a lot of sun, and it's going to be some serious yield hit on this section of this field. And over here, the picture on the right, you can see a person standing here. Well, the sprayer left the pass, and you can see the corn's much taller on the left and the right. And those weeds, the perennial weeds, annual weeds, will grow up through that mat, and they will sap the yield out of those plants. So people will talk more about herbicide later, but we definitely, in the no-till system, we need to consider it. And in fact, one of the reasons no-till has made a comeback is because of the availability of herbicides that work. And so we need to consider that. And so another consideration when we're working with our farmer clients is that we need to instruct them to be patient, and we need to instruct them to be prepared. And that's two of the major keys of making equipment work properly. I have just a slide here that shows that if you're not patient, it doesn't matter whether you're conventional or no-till, it's gonna fail. This is a wet spot in a field. This section here on the left is tilled, and the section here on the right is no-till, and neither one of them did well. The field is too wet. So patient, you gotta wait till the field conditions are right. And the issue in no-till that people need to keep in mind is that the soil may dry out and warm up a bit slower in a no-till system than in a conventionally tilled system. So we need to pay attention to that. The image on the right is what convinced me that it's a system. The planter was working perfectly, dropped the seed right depth, got off and checked it a bunch of times. And the only place in that field that the corn grew was over the tile lines. It was a wet year, and the farmer wanted to convert a hay field into a cornfield, and I showed up and he said, go do it. And I checked the planter, and my pant leg got a little bit wet in the soil, but the planter looked fine. When you're working with your clients, they need to understand that's a totally different system. And typically in a conventional system, they plant until the gauge wheels or the closing wheels start plugging up with soil because of the moisture. Well, in a no-till system, that's not going to happen because there's no loose soil. So the planter is not going to tell you necessarily by looking at it that it's too wet to plant. The farmer's got to make that determination. And on this field here, we didn't get it right, and yields was a total loss. So you got to look at the whole system, and that's what's important. And that this image shows that it's not just the planter; it's a system approach, which is what's going to give us the best results. Patience. Mentioned some of this stuff already, concepts to keep in mind. Soil conditions, we need to avoid planting in cold and or damp soils. We need to make sure that we're addressing the fertility. Banded fertilizer or dribbled on the sides. Totally Tubular is one company that makes systems that you can put on a planter to do either one of those. And so what we're talking about is either putting additional fertility next to the corn seed, not on it, or off to one side. You can also run it through the Keaton seed firmers, which puts some fertilizer directly under the seed, but you need to pay attention to what you're using there. Mostly that's for pop-up fertilizer that won't damage the seed, because certain fertilizers will do that, and we need to be aware of that. The other thing that's required in a no-till equipment system is that to make sure that the equipment is functioning as designed and implemented. And I guess what I mean by that is we need to be constantly monitoring the equipment, the row units, and making sure that everything's working properly. And there's going to be a presentation later about precision ag products, and they really do help with this quite a bit. And depending on the system, the budget, where farmers want to put their money, it's not bad to invest some in being able to monitor what the row units are doing. It's pretty important. So the other key is being prepared. And now I don't think that any of us need to be mechanics. I don't think that's our job. But when we go to work with a client and they show you their corn planter and it looks like this picture, then the pictures on this screen, we need to be somewhat concerned. If I've seen some planters that people are converting from conventional to no-till have no down pressure springs, and or they're broken, or they're just in disrepair, and that's going to be a problem in a no-till system because down pressure is very important. And there's also twisted up parts, worn out, bushings, and worn out sprockets, and worn out idlers. That's what this is. And all those things contribute to variability in the system. And what we're trying to do is be very consistent. And so if you go look at the fellas or gals planter, and it looks in really rough shape, it probably is in really rough shape. And one of the things that we need to do when introducing them to no-till is try to get them to make some improvements to their planter. And this image in the middle is just a demonstration of really what UVM does to their planter every winter, which is go through it, make sure the pieces that make the system work are functioning correctly, which is, this is a V opener, which cuts the slot. This is a seed firmer, which firms the seed. And then in back of that, there's the closing wheels. But all these things need to be in proper order for us to be successful. And so I think as service providers, we need to encourage the farmer clients that their planter's taking on a whole new role, and they need to prepare it to do that. And if they don't, we're just going to run into problems. We have done a lot of modifications to corn planters over the years, and I won't get into everything, but there's I guess what I would say is that when you buy a no-till planter from a manufacturer, they generally aren't set up for the soils that we have here in the Northeast. Most of the corn acres are west, where they have deep, loamy soils, no stones, and they just roll. Here in the East, we have a lot of hard objects in the fields, and the fields are very crooked, and our soils are very variable, I guess. And we go from well drained to poor drained soils in a matter of 50 feet in a field. So we need to make modifications. Even to a new no-till corn planter will have to be modified to work in our soils. And so we have things that we can suggest to farmers, such as, here's a floating road cleaner. This is by Dawn Manufacturing. There's a bunch of manufacturers for these things. I think what's important is that it's floating, which means it follows the contour of the field, right in front of the planter. And we have had fixed road cleaners, and they tend to slice through the hills and bumps, and they actually add variability to the system, which is the one thing we don't want to do. Here is a Keaton seed firmer, and there's a bunch of different types of these. This one happens to have fertilizer tubes on it, but really the purpose of this is to firm the seed in the bottom of the trench. That's super important to make sure that seed is properly placed and properly set in the bottom of the seed trench. Here we have on the lower left is a Thompson wheel. I don't think that the Thompson wheel is the end-all be-all. It's just an example of a closing wheel setup that you can put on a corn planter to make it function better in your system. And then here are the totally tubular setups for people that want to inexpensively add fertility to their row crop. You can add something like this with a tank and a pump, and just dribble on some added fertilizer. So these are things that we would talk to farmers about after looking at their planter, talking to them about what their goals are, talking to them about what their soil conditions are. We would introduce them maybe to some of these concepts. There's always a lot of talk in the no-till world about closing wheels. There's a lot of different kinds of closing wheels. I don't think it's important for our discussion to get into all the different ones, except for to say that they all function a little bit differently, and what we're looking for our soil type is to shatter the sidewall, not compact it. The Thompson wheel, which I showed in the previous one, the one that is on UVM's planter, they work very well, except for when you have stony conditions. Stones will plug them up and becomes a very frustrating ordeal unplugging those constantly in a rocky field. So I guess the point of this slide is that the farmer will have to find what works best for them. Generally, they're not really, really expensive, so there is room to do some experimentation to figure out what works best for their soils. But there, I guess the point of the slide is just to show that there is a lot of choices. And this thing here in the lower left corner is a toe-in wedge or toe-out wedge that goes with the Thompson wheel. So you put this in, it actually angles the closing wheels so they're wider in the front, narrower in the back to kind of pull the soil back over the trench. And that is why they plug with stones, because the back's narrower than the front, and the stones of the particular size don't pass through it. So I don't recommend these in stony soils. So when we're talking about no-till to farmers, farmers want to see something. They want to. We talk about soil health, and the soil health will come, but it comes later. Like the farms that we work on that have been doing no-till for 4 and 5 years, their soils are very different than they were 4 or 5 years ago. But we have to encourage the operator to stick with it long enough to see that. But if we set the system up right and work with them initially, they will see a few benefits immediately. And the first benefit is indicated on the left, which is you can grow no-till corn. I mean, the seed will come up and it'll grow. It'll be fine if we pay attention to certain aspects of the system. The slide on the right, which I got from Kirsten, is a demonstration of a comparison between no-till and tilled ground in clay soils in a wet year. And so what we're seeing is in conventionally tilled ground, the ground's all rutted up, and on no-till ground, there's no ruts. And this may not happen at harvest, but we're up in northern Vermont where we've seen the rutting really bad is when they top dress the corn in June, July, when it's wet. The highboy or the spray rigs really put in deep ruts, and then the farmer's forced to do tillage to get rid of them at the end of the year or the beginning of the next year, and they slam their equipment through those ruts. If it gets dry, they get very, very rough to drive over. But these are some benefits that the farmer can see immediately in year one of converting to a no-till system. The equipment's just going to go on the ground much better, and the crops are going to grow just fine if we pay attention to the details. And I just want to put that slide in there to help with that, help convey that notion. The next slide is the limitations of thinking of the equipment as the system. And so if you just, as I know a lot of programs, we've done it ourselves. We do retrofit. We'll go retrofit a planter. And what I've seen time and time again is if we just retrofit the planter and don't provide the additional support, then the no-till program on that farm doesn't really get off the ground. I try to think of it as the planter is kind of is where all the pieces of the system kind of interact with each other. There I've written each component is added to the planter to control how the planter interacts with another part of the system. So, you know, if you got your disc openers on the front and you put heavy duty ones on, you're trying to deal with a part of your system, which may be stones, maybe surface compaction. If you add a liquid fertilizer system or some kind of, you're dealing with a fertility part of your system. So the corn planter is just a kind of a culmination of how you're working with the rest of your system. It's not the system. You can have, over here I have coulters versus row cleaners. So if you're in heavy residue, you're probably going to want row cleaners versus coulters in many situations. And again, this is farm to farm based on what the goals of the producer are. But I think what's important is to think of it as the system. Don't just be looking at the corn planter saying, well, if you just put on a closing wheel system and some down pressure springs, you should be good to go, without looking at fertility, internal field drainage, and all these other parts of the system, which other speakers are going to address in detail. But I guess what I need you to take away is that it's kind of like balancing the system. And the corn planter, if it's properly set up, will enhance the other parts of the system. So this is a very simple diagram. Planting corn in a no-till system is not very simple. It's got a lot of moving parts in it. So getting towards the end of this part, this is the planter on the farm that I work with that has the 20-ton corn consistently. Started out with 11-ton corn with the same planter. Bought a $6,000 planter out of Pennsylvania, a John Deere 7000. So what's that? Probably 35-year-old planter. Did a few things to it. If you look on the image on the right, you can see that he addresses all the things that no-till wants us to address. He has changed. You can't see in this one, but he has good V openers that cut a trench well. He firms the seed well, and he closes the trench well. And so the system that he has on his farm is not expensive, but he has invested in other things to make his corn growing more and more efficient, like manure injection, and things like that. He cover crops every year. He bought a grain drill to do that. So this is just one part of the system, and we can make it as elaborate or as simple as we want. This planter does have marker arms on it, and he doesn't use those. The high-tech part of this planter is that he has gone to auto steer on his tractor because he couldn't see the marker arms in the cover crop, so he invested in a GPS system, which has helped him a lot, and he'll never go back. He's convinced that this is the way to go, and his yields are proving it. So I guess I put this slide in to suggest to you that you don't need to go out and buy a big fancy planter. What we need to do is look at the system and address the issues in the system, and it'll work just fine with some modifications, I guess. So a few of the types of equipment that no-till equipment that UVM Extension has. So things that we work with, we work a lot with grain drills. So people drill cover crops. A lot of people drill seedings, grass seedings, midsummer, late summer. They want to do no-till, so they'll spray out a field and then want to drill in a new crop in hopes of getting it established before fall for harvesting the next year. That's probably the bulk of our work with the drills. Do I think well over 1,000 acres a year of that anyway. The thing that we run into, different drills do different things. This sunflower drill is a double disc opener, works very well, very dependable. The deer is a single disc opener. It's much heavier than the sunflower drill. And then this S drill uses has a leading edge opener, which works fine. But the interesting thing about the S drill is that it has 5-inch row spacing. So for doing seed downs, it puts the seed in closer proximity to the next row. All three of them work equally well. They all require quite a bit of maintenance. They get used and abused, but that's the name of the game, and they're available for people in northern Vermont to use. But I just wanted to show you that we do more than plant corn. The biggest issue that we have with the drills is calibration. When you're doing seed mixes, you can pretty much throw the metering charts out the window, and everyone's got to calibrate the drills, and people don't. They get in a hurry and they get disappointed. If they had taken the 10 minutes to calibrate them or ask for help doing it, they usually come after the fact and say that, oh, I had 200 pounds of seed left over, and you're like, well, you should ask for help calibrating the drill. And so anyways, that's the biggest thing is calibration with those. They work well. We also have 2 interseeders that we use for no-till, putting cover crops in. And they act very similar to a drill. They are a drill, except for they got row units missing to allow for the corn rows to pass through. We have an interseeder technologies 6-row interseeder, and we have it's made by Zimmerman Manufacturing out of Pennsylvania, and it's a 6-row with a Dawn Biologic duo-seeder setup on it. 2 very different systems. This uses a seed meter to meter the seed out, and this uses an air-based blower system. So it just spills the seed into some cups and blows it down these tubes. Both of them work equally well. The interseeder has 3 rows between each row of corn, and the duo-seeder only has 2 rows between each row of corn. And I guess the preference I have is for the duo-seeder, because it can be turned and pulled down the road narrow, where the interseeder is 15 feet wide down the road. So it makes it a little more difficult to move around. But they both are very good at interseeding cover crops. And we have different levels of success with this. Not going to get into too much detail, except for to say that herbicide programs make a huge difference when you're seeding. When the corn is at V4 to V6, there's still a lot of opportunity for the herbicides to impact the establishment and growth of any cover crop you put in. And that's probably our biggest single issue year over year is herbicide interaction. And the other one is just the idea of planting a cover crop in with your row crop. The shading and drought tolerance of your cover crop comes into play, because it's going to get shaded out when the corn canopy's over, and it's gonna be starving for water if the roots don't get down very far before it dries out. And so that's a consideration that people need to make. And we have found that higher seeding rates do produce better results in general. So that's been helpful to know. The last piece of equipment that I'll talk about is our white planter, the one that we've done so much no-till work with. Right now, it's gone through a lot of modifications over the years. Just over the 6 years, it was here at UVM when I came. I think they had it for 3 years, so it's pushing 10 years old now. It's done a lot of acres. The picture on the right shows how it was originally, and so originally there was a zone tiller on it. So I'm sure folks can relate to this, but the idea of doing no-till years ago, at least in this area, was we're going to do no-till, but we're going to do as much tillage as we can while we're only driving the corn planter over the ground. So no-till kind of meant taking all the tillage tools away and just running the planter. But essentially what we've done here is we've put tillage equipment on front of the corn planter. And we also had on the planter totally different setup the whole way through. This is a coulter, a fixed row cleaner with a fixed coulter and some weird closing wheel system. That was 6 years ago. Today the planter's totally different. This stuff's all gone. We have put the roller crimper on in the last 2 years. We went to a floating row cleaner, and we went to Thompson closing wheels, which you can see in the image on the left. And we also have drastically modified the fertilizer system. And so the point of this is that, you know, the planter is the final link in the no-till corn system that the farmer creates on his farm, but that it's not really ever finished. It'll evolve over time as the farmer and the people that are helping him identify different needs in the system that the planter might help address. And so every year, UVM's planter gets changed to try to make it work better. And what we're trying to do is get it to work the best it can over the widest range of soils and field conditions. So I just wanted to throw this slide in there so that you could see that it's not a static system, it's a dynamic system, and the planters are pretty much constantly getting modified. So if you're working with a farmer and he says something didn't work, you know, they tried something, I don't know, closing wheel maybe, or a row cleaner, and they aren't getting good results with it, then that shouldn't really surprise anyone. Every farm goes through a few iterations before they get it right. And so we should keep that in mind when we're working with our clients, that very seldom do we get it perfect on the first try, but that just means we keep on trying. So that kind of brings me through to the end of the presentation. And some thoughts that we should keep in mind. We need to meet the demands of the system you're using the equipment in. So it has to be set up properly. And what that means is that we need to get the piece of equipment to function as it was designed, or as we need it to, given the conditions that we're putting it to work in. And that's why a conventional planter set up for conventional tillage very seldom will work well in a no-till system. It's going to have issues with the V openers. It's going to have issues with the down pressure springs. It's going to have issues with the closing wheels likely. So we need to consider this and get it set up properly. And us as service providers, I don't think it's our job to set the planter up, but it's our job to help the farmer identify possibly weaknesses in the setup and be able to steer them in the right direction, to talk to somebody, a vendor or internet, something to figure out how to better set up the planter. the planter must be well maintained. It's the piece of equipment that is now doing all the work. In the Moodle section, there's a planter checklist that we've put on for anybody to grab, and there's a bunch of, I think it's like 5 pages long or 3 pages long of things to check on a planter that'd be good to provide your clients so that they can check some things on their planter to see where they're at. The maintenance on the planter is all about reducing variability in the system. We really want a very consistent, the process of planting, we want it to stay the same all the time. And we can't do that if different row units are behaving differently from one another. It's going to introduce variability, which is going to take away from yield, which is going to make the producer discouraged, which is going to further impede us going in the direction that we want to go in. More importantly, in a no-till system, we've got to constantly monitor what the planter's doing. Sometimes we're planting on very hard soil. Sometimes we're planting on rough soil. The soil surface is rough, and we need to somehow monitor what that planter's doing, either using precision ag or just the farmer's got to be willing to look back and make sure, get off the planter and make sure that the row units are functioning as they are supposed to be and expected to perform. So if you set the planter up in the morning and don't look at it again to the end of the day, or I know this happens quite a bit, the seed monitor will have something wrong with it, you know, at 11 o'clock in the morning, it'll start beeping at you, and the farmer just shuts it off rather than stopping to fix it because he feels like he doesn't have time. And then something goes wrong with a row unit and plugs or something, and they don't catch it for an hour and a half or 2 hours. And then that's when you're driving down the road and you see fields that have 5 rows where they're supposed to have 6, or if it's an end row that goes bad, you'll see 2 row skips in the field. And it has to do with making sure that everything is monitored and performing. Really, the process of growing corn in today's world is so expensive. You know, corn seed is $300 to $500 a bag. The fertility, the land rent. Kirsten will get into this in her presentation, I'm sure, but we can't afford to do it wrong. So it has to be monitored while we're doing it, and that's very important that we share that with our clients. Another take home is that it doesn't need to be elaborate. It just needs to work. And I showed you that farmer's planter. That's a very simple planter, and it works very well, but it's very customized, if you will, to his system. He's addressed a lot of things on his farm that make that work well for him. And we as service providers need to do that. And other speakers will provide information on other parts of the system, but we need to make the equipment match what the farmer has going on. And say a farmer has very poorly drained soils on most of their fields, we're not really going to address that very well with the corn planter. We're going to need to address that through some other means on the farm, or we're going to have a hard time doing no-till in those poorly drained soils. And I guess that's my final point, is that we just need to consider these things in the larger scope of what's going on with the cropping system on that farm. So that's my last slide. I thank you all for listening. I